We know that a molecule is made from two or more atoms. In this video, we will learn to categorize a molecule into different categories based on number of atoms and type of atoms. Let's first learn about different type of molecules based on number of atoms in it. There are some matter around us which exist in the form of single atom. These matter are called monoatomic molecule. Let's try to understand it by an example. In copper, various copper atoms bind together to form the copper as we see. Each copper atom has same property as the big size copper matter. But in case of monoatomic molecule, atoms do not make any bond with similar or different type of atoms. They remain independent. All the inert gases, helium, argon, neon, krypton, xenon, and radon are monoatomic molecule. There are some molecules which are made from two atoms. These molecules are known as diatomic molecule. Oxygen gas, nitrogen gas, hydrogen gas are examples of diatomic molecule. When a molecule contains three atoms, it is called a triatomic molecule. Water, carbon dioxide, and sulfur dioxide are examples of triatomic molecule. Molecules with four or more than four atoms are called polyatomic molecules. Sulfuric acid, phosphate are examples of polyatomic molecule. Now let's learn about different molecule based on type of atoms. When a molecule is comprised of same type of atoms, it is called molecule of elements. Oxygen molecule has two oxygen atoms. Ozone has three oxygen atoms. Both oxygen and ozone are molecule of elements. When a molecule has different type of atoms, it is called molecule of compounds. Water molecule has two hydrogen atoms and one oxygen atom, so it is a molecule of compounds. Carbon dioxide has two oxygen atoms and one carbon atom. It is also a molecule of compounds.
In this lesson, we will learn about what ions are and how they are formed. When an atom gains or loses electrons, they develop a charge. Recall that electrons are negatively charged, so the gain or loss of electrons will create a charge. These charged particles are called ions. When an atom loses electrons, they become positively charged. Positively charged ions are called cations. An easy way to remember this is to recall that cats have paws. When an atom gains electrons, they become negatively charged. Negatively charged ions are called anions. Let's look at sodium as an example. Its electronic structure is 2, 8, and 1. It has one electron in its valence or outermost shell. When sodium loses this valence electron, it becomes a positively charged sodium ion. This charge is written as a superscript when writing the symbol. When drawing the electronic structure, enclose it in square brackets and write the charge on the top right-hand corner. Now, let's look at oxygen as another example. Its electronic structure is 2 and 6. Therefore, there are 6 electrons in its valence shell. Oxygen gains 2 electrons to form a negatively charged oxide ion. Remember to include the charge when writing the symbol and when drawing the electronic structure. If we look at the electronic structure of these two ions, we will see that they have a complete outer shell. We will also see that they have the same electronic structure as that of a noble gas. The sodium ion and the oxide ion have the same electronic structure as a neon atom. How are you feeling about ions? Are you ready to form ions on your own? Let's try. Please pause the lesson and draw the electronic structure of a calcium ion and a chloride ion. The electronic structure of calcium is 2, 8, 8, 2. It loses 2 valence electrons to form a calcium 2+ ion. The electronic structure of chlorine is 2, 8, and 7. It gains an electron to form a chloride ion. These two ions have the same electronic structure as an argon atom. Did you get the structures right? And did you remember to specify the charges? What do sodium and magnesium have in common? They are both metals, and metals lose their valence electrons to form cations. Group 1 metals, such as sodium, have 1 valence electron, and they lose this electron to form ions with a +1 charge. Group 2 metals, such as magnesium, have 2 valence electrons, and they lose these electrons to form ions with a 2+ charge. Oxygen and fluorine are both nonmetals. Nonmetals tend to gain electrons to form anions. Oxygen is in group 6 and has 6 valence electrons. It gains 2 electrons to form an ion with a -2 charge. Fluorine is in group 7 and has 7 valence electrons. It gains 1 electron to form an ion with a -1 charge. Group 3 elements, such as aluminum, lose 3 electrons to form ions with a +3 charge. Group 5 elements, such as nitrogen, gain 3 electrons to form ions with a -3 charge. Group 4 elements, such as carbon, tend to form covalent compounds. Stay tuned. In conclusion, an ion is a charged particle formed from either the gain or loss of electrons. A positively charged ion is known as a cation, and a negatively charged ion is known as an anion. The ions formed have the same electronic structure as their nearest noble gas.
The relative isotopic mass is the mass of an element in relation to carbon-12. The reason that this is the isotopic mass is because some elements have different isotopic forms. For example, chlorine can be found as chlorine 35 and chlorine 37. The isotopic mass is not the mass number which appears on the periodic table. The number seen on the periodic table is the relative atomic mass, or the AR. The relative atomic mass of an element is defined as the average mass of the naturally occurring isotopes of the element relative to the mass of an atom of carbon-12. On the periodic table, it is the same number as the mass number. In basic terms, it is the average mass of the isotopic forms of the element. When we think about this, we must remember that isotopic forms of elements have different values for their naturally occurring abundance on Earth. For example, let's look at the isotopic forms of chlorine. Some chlorine atoms have a mass of 35, and some have a mass of 37. In most cases, to take a simple average, you would just add the values together and then divide by the number of values. In this case, it would be 35 plus 37 divided by 2, and you would get an average of 36. But this is not how you calculate the relative atomic mass. We need to remember that we are talking about number of atoms. There are a certain number of chlorine atoms with a mass of 35 and a certain number of chlorine atoms with a mass of 37. However, within a sample, the levels of each isotope are not equal. So we take this into account when we are calculating the relative atomic mass, so that we are calculating a weighted average. Naturally occurring chlorine is made up of 75% chlorine 35 and 25% chlorine 37. This can be shown to you on a graph to show abundance data, where the relative isotopic mass is shown along the x-axis and the relative abundance is shown on the y-axis. So say we had a simple sample of 100 atoms of chlorine. We would have 75 atoms of chlorine 35 and 25 atoms of chlorine 37. We first find out the total mass of the sample. We do this by multiplying the mass of each atom by the number of atoms present for each isotope, and then we add them together. For chlorine 35, there are 75 atoms, and for chlorine 37, there are 25 atoms. So the mass of 100 atoms would be 75 times 35 plus 25 times 37, 3,550. The mass of one atom will be the mass of the total number of atoms divided by the number of atoms. So the mass of one atom of chlorine would be 3,550 divided by 100, 35.5. The relative atomic mass has a value closer to 35 because there are more atoms of chlorine 35 than chlorine 37. It is a weighted average. So the relative atomic mass of an element is defined as the average mass of the naturally occurring isotopes of the element relative to the mass of an atom of carbon-12. On the periodic table, it is the same number as the mass number. The number is a weighted average, and when calculating its value, the proportion of an isotope in a sample must be taken into account. All atoms of a particular element have the same atomic number. This means that they all have the same number of protons. But sometimes you can find heavy atoms of a particular element. These atoms have a higher mass number. The mass number is equal to the number of protons plus the number of neutrons. We can ignore the electrons as their mass is so tiny. If the number of protons always stays the same in a particular element, and we are ignoring the mass of electrons, it must mean the number of neutrons is causing the difference in mass. Atoms of the same element with a different mass number are known as isotopes. They are defined as atoms of an element which have the same number of protons but a different number of neutrons. If we look at carbon and nitrogen, are they isotopes? They have different mass numbers, but they also have a different number of protons. Therefore, they are not isotopes. They are completely different elements. Different isotopes of elements do not have separate positions on the periodic table. They occupy the same spot because they have the same number of protons. What about carbon-12 and carbon-14? Both carbon-12 and carbon-14 have the same atomic number, which means they have the same number of protons, but they have different masses. Carbon-12 has a mass of 12 and 6 protons. Remember, mass number equals protons plus neutrons. So we can rearrange this formula to give us neutrons equals mass number minus protons. 12 minus 6 equals 6. Therefore, it has 6 neutrons. Carbon-14 has a mass of 14, but it still only has 6 protons. Mass number equals protons plus neutrons. Rearrange. Neutrons equals mass number minus protons. 14 minus 6 equals 8. Therefore, carbon-14 has 8 neutrons. Carbon-12 and carbon-14 are not the only examples of isotopes. There are many more, such as hydrogen, deuterium, tritium, and chlorine-35 and chlorine-37. Isotopes only differ in their number of neutrons and their mass. Their chemical properties are exactly the same because neutrons have no effect on an element's chemical behavior. This is controlled by electrons, which we will discuss in another video. So isotopes are atoms of the same element with the same number of protons but a different number of neutrons. They have different masses, but their chemical properties are exactly the same.